Hi, everyone. So today we are taking a look at stoichiometry part one. And really, this is going to be more so of a 2 or 3 part series that has all of the foundational content that you need for this topic. When it comes to Stoic, it's super important. You just can't put off Stoic because a lot of the other topics in Gen Chem heavily rely on stoichiometry. And you're going to see that today. So the first thing we're going to quickly do is just do a quick understanding, a quick recap of periodic table elements. So whenever we think about our periodic table, we know that each element on the periodic table is typically going to be presented in a box. And whenever you have the element of interest, you'll have its 1 letter abbreviation in the middle. So this will be the symbol for the element. And in this case, it refers to carbon. And then up at the top, you'll see a number. So for carbon, you'll see the number 6. And at the bottom, you'll see the number 12. So the number 6 is important because this is the atomic number. And the atomic number is going to give you the identity of a given element. And what I mean by identity is a lot of the properties that an element has, such as its boiling point, its melting point, things of that sort, those are all due to this atomic number. So if you change the atomic number, you change the properties of that element. So just keep that in mind. Now, at the very bottom, we have our atomic mass. And our atomic mass isn't as serious as the atomic number in the sense that you wouldn't say something like the atomic mass is the identity of an element, not so much. So the reason why I'm mentioning the periodic table elements is because this information is super useful in the concept and topic of stoichiometry. I want to fixate just a little bit on the atomic number and on the atomic mass and how we can particularly use these to actually do a lot of subsequent calculations in stoichiometry. So if we think about our atomic number, remember it's the one at the top, this corresponds to the number of protons and the number of electrons in a neutral atom. So if we think about this, let's kind of take a look at carbon. How many protons does carbon have? It's going to have 6. How many electrons does it have? Well, if carbon's just neutral, we're going to say it also has 6 electrons, like that. So the atomic number gives you a lot of information about the protons and electrons. Now, the atomic mass, which is that number at the bottom, tells you the number of protons plus the number of neutrons. And so in this situation, if you see the value of 12 down here, let's go ahead and ask ourselves, how many neutrons does carbon have? So if you wanted to ask that question or answer that of how many neutrons does carbon have in this situation, you would just use the atomic number first and figure out the number of protons. So how many protons do you have? Using the atomic number, it would just be 6. So remember that your atomic mass, 12, is protons plus neutrons. So how many neutrons do you have? And it would just be your atomic mass subtracted from your atomic number. So 12 minus 6 is 6, like that. And then you're pretty much good to go. So here, as you can tell, this one identity, I guess this one figure here tells you a lot of important things about each and every element. And that is what we're going to heavily rely on today as we start doing some stoichiometric problems. So now what I would like for us to do is quickly go down and actually start diving into the meat of stoichiometry. So when it comes to stoichiometry, a large part of it is going to involve metric unit conversions. So metric unit conversions are if someone says, how many grams are in a kilogram? How many kilograms are in a gram? Like that. It's basically where you're trying to convert from one unit to another. So as you can tell here, there's several metric units that you have to know and several symbols and several scientific notations. So the easiest way to kind of put this is, unfortunately, you want to memorize all of this. You want to memorize every single column here because it might come up on test day. And I think the best way to actually dive into this is just by doing a couple of problems. Now, before we dive into each of the problems, I do want to give some math tips. And it's going to be the following. When you divide exponents, so let's say I have 10 to the 6th divided by 10 to the 4th, you subtract. So it'll be 10 to the 6th minus 4 is 10 to the 2nd. So when you divide exponents, you subtract them. Now, when you multiply exponents, so 10 to the 6th times 10 to the 4th, you add them this time around. So it'll be 10 to the 6th plus 4 or 10 to the 10th, like that. And so these are just a few quick notes that I want to give you guys because these little math tricks and tips, honestly, will kind of help you out when you're doing these calculations here. So let's go ahead and try our first example. And I'm going to go ahead and erase some of this stuff, and I'll just put our little tips and tricks up here so that we can reference them. All right, so let's try our very first example. So if I have 500 nanograms and I want to convert to grams, that is my first question. How would I do that? And it's going to be in a series of steps. First, you always want to ask yourself, what exactly are we starting off with? In stoichiometry, you always want to write out what you're starting with. So I'm starting with 500 nanograms. So I'm going to write this here. And if I want to get to grams at the end of the day, where would I need to put nanograms so that it cancels, in the numerator or the denominator? You would put it in the denominator here, and then you put grams up here. So now we have to basically use our table here and find nano. So nano corresponds to 1 times 10 to the minus 9. That means it is that much smaller than a gram. This is the conversion for 1 gram. So 1 gram is equal to 1 times 10 to the minus 9 nanograms, like that. So oftentimes when I teach this to students, they get a little confused. So I have a little bit of a shortcut that I'd like to kind of show you all. And I think this is beneficial for you to use at the very beginning. So the shortcut is as follows. If the unit of interest is smaller than the base unit, flip to a positive number and stick it next to the base unit. And I'll explain what I mean, because maybe that sounds like gibberish. So when I'm talking about nanograms and grams, what is my base unit? If I'm hypothetically saying kilograms, femtograms, milligrams, decigrams, what is my base unit? My base unit is just grams. Grams is kind of the base unit that you're working with. How about if I was talking about milliliters, kiloliters, megaliters, microliters? What's your base unit? It's going to just be liters. So the first step here is your unit of interest smaller than the base unit? Is nanograms smaller than a gram? And it is. You can see that it's 1 times 10 to the minus 9. So we're satisfying this first rule. What you then do is take that 1 times 10 to the minus 9 and you flip it to the positive number, 1 times 10 to the 9th. Now this 1 times 10 to the 9th, you want to stick next to the non-base unit. So who is the non-base unit in this situation? Is it going to be grams or is it going to be nanograms? Who is the non-base unit? It's going to be the nanograms. So we're going to stick it right there. And so finally, this is how you would set up your equation. And if we were to rearrange this, it's 500 over 1 times 10 to the 9th, because nanograms cancel. I'm going to convert to scientific notation. 5 times 10 to the 2nd over 1 times 10 to the 9th. So 5 over 1 is 5. And then if I'm dividing, remember, when you divide exponents, what's the rule? What do? Do you add, subtract? When you divide, you subtract. So you subtract 2 minus 9. This is 5 times 10 to the minus 7 grams. And that is the best answer here. So let's try another example, because usually this kind of stuff will only make sense if we do multiple examples. So let's say that we are now looking at, let me come up with one on the fly. Here, let's do this. Convert 300 milligrams to grams. Let's try that one. What's my first step? It's simply to write down what I've been given. So 300 milligrams, set up my skeleton. So milligrams goes on the bottom, grams goes on the top. So now I'm good. Now I'm going to isolate milli on the table. Remember, you would have had to memorize this. So ask yourself, does this satisfy the rules that I'm pointing out right over here? And it does. Is milli a unit of interest that's smaller than the base unit? And it is, because it's 10 to the minus 3. So what do? When you get 1 times 10 to the minus 3, what's the second step in the box? You convert it to a positive number, 1 times 10 to the 3rd. And who do I stick this next to? Grams or milligrams? You're going to stick this next to the milligrams, the non-base unit, because grams is the base unit. Now we can go ahead and solve. Milligrams cancels. And then you have 300 over 1 times 10 to the 3rd, which is 3 times 10 to the 2nd over 1 times 10 to the 3rd, which is 3 times 10 to the what? 2 minus 3, 3 times 10 to the minus 1 grams. And that's how you would get to this. All right, let's try a slightly different example. A little different, but overall, it's going to be somewhat of the same thing. This time, I want you to know a second set of rules. This is when the unit of interest is larger than the base unit. You will keep as a positive number and stick next to base unit. Okay, so let's go ahead and get started. What if I told you how many kilograms are in 1 gram? Let's start with that. You always start with the thing that has 1 unit. So what is the thing that has 1 unit in this situation? Or the thing that I'm given, I should say. It's going to be 1 gram because you're trying to solve for kilograms. Then you set up your skeleton, grams and kilograms, and then you isolate kilo on this table, which you would have memorized. So notice the second set of rules down here. This unit of interest is larger than the base unit. A kilogram is much larger than a gram. So what I'll do is take 1 times 10 to the third. Do I flip the sign at all? Do I make it 1 times 10 to the -3? No, you just keep it as a positive number. And who do I stick this next to? I stick this next to the base unit. So is it going to go in my numerator or in my denominator? It's going to go in my denominator next to the base unit, like that. Then I just go ahead and solve. So grams cancel, and it's 1 over 1 times 10 to the third. 1 over 1 is 1. And this is going to be times 10 to the -3. I want to explain that just a little bit more. In the numerator, since it's just 1, that's the same as saying 1 times 10 to the 0. You can basically assume that that's what that means. So since we're dividing, you just do 0 minus 3 for the exponents. And that's how I got this -3 right over here. All right. Let's try another example to kind of drive this home. Let's say, how many megagrams are in 10 grams? Let's try that one. So for this, again, you start with what's given. So 10 grams. Set up your skeleton. And then you put grams in the denominator and megagrams in the numerator. And that's a capital M. You go ahead and isolate mega, and it's 10 to the 6th. So is this a larger or smaller than your base unit? Well, it's much larger. So you use the second set of rules down here. You keep 1 times 10 to the 6th positive. And where do you stick it? Numerator or denominator? Next to the megagrams or next to the grams? You stick it next to the grams. And then you just go ahead and solve. Grams cancels. You have 10 over 1 times 10 to the 6th. So we can convert to scientific notation. 1 times 10 to the 1st over 1 times 10 to the 6th. So 1 over 1 gives me 1 times 10 to the 1 minus 6, -5, like that. And that's megagrams. So now it should be a little bit more feasible on how we're interpreting these values in this table and setting up the equations. You want to feel comfortable with this. You don't want to kind of push this part off because it comes up again and again. All right. Now let's take a look at a slightly different example. This one's going to kind of test to see, has everything up until this point made sense? So a little bit more complex of an example where we're going to use more than one step. So the question's going to be, how many femtograms are in a kilogram? So here in this situation, how many femtograms are in a kilogram? That's a little different from everything we've looked at up until this point, right? Because we've always taken everything from some strange unit back to the base unit, from femtograms to grams, kilograms to grams. We've never really had to do something where it's like femto to kilo directly. So this is slightly different. But again, I think we can do it. I definitely think we can do it. So here, what are we being asked to solve for? Are we being asked to solve for femtograms or kilograms? We're being asked to really solve for femtograms, right? How many femtograms? And what we are given is actually the kilogram quantity. And specifically, how many kilograms are you assuming? It's just 1 kilogram, like that. So what we're going to do is start off writing our equation. Remember, you write with what you're really given. And so I'm going to go ahead and write 1 kilogram and set up my equation. Kilograms. And what should go in the numerator? What should I convert the kilograms to? What has been the conversion I've used up until this point? It's probably going to be grams, the base unit. Then from grams, I can go ahead and put femtograms like that. So let's start with the kilogram part. So the kilograms right here, 10 to the third. It's the number larger than the base unit. You keep it as a positive, 1 times 10 to the third. And where do you put it according to the rules? You put it next to the base unit. So I'm going to sneak this guy in right up here, like that. All right, next one, femtograms. Femto is going to be all the way down here. And that is 1 times 10 to the negative 15, meaning it is smaller than the base unit. So you have to flip it to a positive number. And then who do you stick this next to? You stick it next to the non-base unit. So is that femto or grams? It's going to be femto, like that. And then you just have to make sure all your units cancel. So kilograms cancel, grams cancel. And at this point, we can just write our equation. 1 times 10 to the third, 1 times 10 to the 15, all over 1. And remember, when you multiply exponents, what do? Do you add or subtract? You add, and so it's 1 times 10 to the 18th femtograms. So not too shabby at all.